Hi, in this video we're going to be looking for the area of various polygons. Now all these polygons are mostly going to be coming from this idea of a rectangle. You've done this for a long time, length times width, that gets you the area of our shape. But if we're doing that with a parallelogram, note that it is the exact same formula, two numbers getting multiplied together. The reason that is, I've got another little parallelogram here, is if I imagine this getting cut over to the other side, so I just cut this off here. So if I cut this little triangle off, I can bring that triangle to the other side, and then boom, that thing is a rectangle. So the idea of moving this triangle to the other side makes it the same formula for the area of a parallelogram as well as the area of a rectangle. So in this example where we're trying to find the height of this parallelogram, I want to know how big that is. I know that's 5.8. I could also find the area of my parallelogram using this as the base and 3 as the height because the 4 and the 3 are perpendicular. Base and height are perpendicular. So I could say that the area of this parallelogram is 4 times 3. So that's going to be 12. So that's how big that parallelogram is. I can use that same idea to figure out what this h is and the 5.8 by still finding the area again. The area should be the same if I use those red numbers as I did when I found the area with these two blue numbers. So that 12 should be the same as finding the area with the other two. So 5.8 times whatever the height is. So that means h is equal to 12 divided by 5.8. And when I type that into my calculator, I get, it's not 4, it's approximately 2.07. For the height if I go this way with this base, while the height was 3 if I use 4 for my base. Now this shape isn't a parallelogram, but it does seem to be kind of rectangular. So what I want to figure out is what the area of all the parts are of this shape, because I don't have like a cross formula. And then once I find the area of all the parts, I could add them up and I should get the total area. Because I can see right up top here, there is a cool little rectangle. There is also a cool little rectangle down here on the bottom. So those two rectangles, I can find those areas pretty quick. So that's 4 times 6, so that's 24. And then the rectangle on the top is also going to be 4 times 6, so that's 24 as well. So now all I have to do is I need to find the area of this rectangle in the middle here. Now keep in mind, if this is 14, then this has got to be 14 as well. I need to figure out this whole length here. So that's 14 plus 14. And this thing right here, oh, that's 6 from those other two bits. So the area of this has got to be 4 times 14 plus 6 plus 14, making sure I'm going all the way across this rectangle. So that area is going to be 4 times, let's see, that's 20, 34. So my total area, well, my area of that piece is going to be 4 times 34, which is 136. And so my total equals parts. My total area is going to be that 136 plus the 24 from the top rectangle and the 24 from the bottom rectangle. So 24 plus another 24. So I just need to type that into my calculator, 134 plus 24 plus 24, and I get 184. And so that is my total area. Whenever you get big shapes like this that are not quite exactly what we have a formula for, break it up into shapes that we are able to find the formula of. Our next formula we're going to take a look at is the area of a triangle, which is 1/2, and it's still base times height. So it's the same as a parallelogram, but it's got this 1/2 on there. Because if this is my triangle, if this is my base and my height, then I could really unfold this and say, hey, that's actually two of those triangles, and that makes a nice square. But I only want this side of it. I don't want this side of it. So if I take two of those from the square and then cut it in half, boom, you've got yourself a triangle there. So that's where that comes from. We've got the lengths of the sides of a right triangle are these measurements. We got to figure out which one of these has got to be the area of a triangle. Now we got to be careful here because we know that area is just base times height, but I was given three numbers. So one of these has got to be useless. I want to make sure when I'm finding that area, I'm doing base times height. That base and that height have to meet at a right angle, just as they were meeting before. When I'm drawing a right triangle, I know the side opposite of my right angle is got to be the longest side, that 26. This 26 is longest, so it's got to be the hypotenuse. So that makes 10 and 24 the two legs of my triangle. So 10 and 24, I'm going to put them that way. You could like reverse it the other way. It doesn't really matter. Really, we just need a base and a height. It doesn't matter what order you multiply them in. So the area of this shape has got to be 1/2 times 10 times 24. So that area equals half of 10 times 24, that's 240, which equals 210. So it must be this value right there. Note that since this is an area, area uses squared because it's a two-dimensional shape, while a length of a side is just going to use inches because it's a one-dimensional shape. It just goes left and right and up and down. This is talking about the area of all of that space inside of the shape. This next formula is the area of a trapezoid. It's a little bit weirder. We still got height times base, but there's a couple bases now because there are two sides that are perpendicular to that height. So rather than choosing between them, we're going to kind of do both. And the way that happens is in our trapezoid, we're kind of like taking these two little triangles and cutting them off. So I'll snip this guy off and snip this guy off. Oh, and once you cut those off, hopefully well, you're able to kind of like even out the two sides so that the two sides are even. And once you even out those two sides, you've got yourself a square if this would like lay nicely and make and be cut nicely. So it is sort of like averaging the two together so you get a nice even shape. I'm not going to super test you on that, but just so you know where this is coming from. So when I'm finding the area of this guy, I want to find the two bases. My bases are perpendicular to the height. So this has got to be B1 and B2. It doesn't matter which one is which. I'm just going to number them that way. And then this is our height because it's perpendicular to both the 10 and the 24. Note here that this is not used because it's not perpendicular. We just want sides that are perpendicular to the height, and we want our height to be perpendicular to our two bases. So the area of this trapezoid is going to be 1/2 our height, which is 6, multiplied by our two bases added together. So that's 10 plus 24. So if we simplify that down, 1/2 of 6, that's 3. 10 plus 24, that's going to be 34. And then 3 times 34 ends up being 102. So the area of this shape is 102 inches squared. Great. Now down here in this shape, I don't have a trapezoid. I mean, I kind of do right here, but I've also got this weird fin off of the top. So this is a figure that we don't have the formula for. So we want to do our same total equals parts. If we find all the parts of this shape, we're going to be able to figure out what the total area of this shape is. First, we've got a triangle on the top. So we got a nice triangle. And then on the bottom, we got a trapezoid, which we were just talking about. So this total area has got to equal total has got to equal the area of the trapezoid plus the area of the triangle. So area trap plus the area of our triangle. All right. So we just got to figure those out one by one. So the area of a trapezoid, we were just talking about, that's this thing. So 1/2 our height, and then our two bases added together. So our height is right here because it's perpendicular to our two bases. So we've got 1/2 the height of our trapezoid, which is 4, the thing that's perpendicular to our two bases, and then 6 plus 12, the two things that 4 is perpendicular to. Then we got to add on the area of this triangle. The area of a triangle is 1/2 our base and our height. So we want the two sides that are perpendicular to each other. Note that this side kind of like extends out in order to be perpendicular to that 4. So that's 6 times 4. So now we just got to simplify that down. Half of 6 is 3. So this is 3 times 4. Then over here, we've got half of 4, that's 2, and 6 plus 12, that is 18. 2 times 18, so the area of our trapezoid is 36, and the area of our triangle is 12, so 36 plus 12, our total area is 48. And do I have a measurement on here? Yeah, 48, we'll just say inches squared. I don't know if these are inches or what, but we'll just say they're inches. So next we have the area of a rhombus or a kite. To find the area of a rhombus, you want to do the two diagonals. So if this diagonal here is 9, so all of that is 9, and then this diagonal is 4 plus 4, so that's 8, then the area of that shape is going to be half of the two diagonals multiplied. And the reason that happens is if we think about this shape right here, really what's happening in the background is that there's another shape that's behind it. And that other shape that's behind it is a square with length and width. But note that as I kind of like fold that back into a trapezoid, there's kind of like two areas. There's this area here, and then the folded up bits on the back. So if I multiply these two diagonals together, the area that I'm getting is too much. It's the front and the back. I just want this side of it, so that's why we get this divide by 2. So if we wanted to find the area of this rhombus, we would say, oh, if that's 12, then this is also 12. So I know that this diagonal here is 12, but I still got to figure out this other diagonal here. In order to find that, I am probably going to need to do a little Pythagorean theorem because this is making a nice right angle. And I've got 20, right angle, and x. So I can apply the Pythagorean theorem here. So 12 squared plus x squared equals 20 squared. And then once I find that x, I'll find half the diagonal, multiply it by the other diagonal. So 144 plus x squared equals 20 squared, which is 400. Subtract a 144 from both sides. X squared equals 256. So that means x equals plus or minus the square root of 256, which I'm pretty sure is 16. Yeah. So x has got to equal 16 because I just want that positive case. So that's 16 and that's 16. So we can find our area of this trapezoid. Nope, sorry, rhombus. It'll be 1/2 our first diagonal times our other diagonal. So we've got the red diagonal, which is 12 plus 12, because we don't want just this part of it. We want all of it. And then we've got the other diagonal, which is 16 and 16. So 2 16s. Great. Now note up here, again, this diagram isn't drawn very well. I wanted this whole line here to be 9. So it's 4 and 4. That's why I'm not adding 2 9s right there. The whole line is 9. Let's see what this equals. So area equals half of 24 times 32. So the area is half. Nope, 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 nope. 24 times a half. That's 12 times 32. So my area is just whatever 12 times 32 is, which is 384. And these were in kilometers. So I want to make sure that this is kilometers squared because I'm talking about area. Area will use squareds. Now I don't have a sticky note circle thing because it's actually been proven that you can't square a circle. So I can't like unfold a square somehow and turn it into a circle. So that's just mathematically impossible. So instead, I want you to still be thinking about, hey, finding the area of this thing. It uses this formula. And the way it is able to kind of get to some sort of like, kind of like length times width or base times height is this idea of pi. Really, the base and height is right here, and pi is evening things out. Pi is approximately 3.14. You can use that, or you can use the pi button on your calculator. So let's try it out. I've got this shape here, and I'm looking for its area, but that's not a circle. I've got a rectangle down here. So, and then on the top of it, I've got half of a circle. So this is a circle cut in half. And then on the bottom, I've got a rectangle. So if I want to find this thing's area, if I think about total equals parts, I've got to find the area of that rectangle plus whatever the area of that circle is divided by 2. So the area of the rectangle, that's easy. 6 times 4. So 6 times 4. Done. The area of the circle, however, I got to be careful. Reminder, we're using pi r squared, not pi times the diameter squared. So 2 times the radius, that is our diameter. And in this case, our diameter is 4, going all the way across that circle. So if I want to find what the radius is, you divide them both by 2, divide that 4 by 2, and you get 2. So the area of my circle is going to be pi times 2 squared divided by 2. Sorry, those aren't lined up very well at all now, are they? Disgusting. Tota? How about total? So our total area, total, is 6 times 4, which is 24. Pi times 2 squared, which is 4 pi divided by 2, because we still got that divided by 2. And so that is 24 plus 2 pi. Now this is leaving your answers in terms of pi. That is what we just did, 24 plus 2 pi. So that could be our answer. It also is asking us to give our answer rounded to the nearest tenth, or sorry, hundredth. So that means we're going to put this into our calculator and see what it spits out using that pi button. So 24 plus 2 pi is 30.28. So that is rounded to the nearest hundredth. I am going to be kind of asking for both of those things in the thing. Now, this example might not look at is one of those where I don't know what these shapes are. They're kind of like squaredy circle guys. So I need to figure out what the area of all of this stuff is, and we'll call the squiggly stuff, we'll call that X. So that's the area that we're actually trying to find. To find it, we're going to need to use what is our total area. So we've got all this stuff out here, which is a square. And then inside of it, we've got this circle. So if I think about my idea of total equals parts, I've got to figure out, hey, we've got the area of a square. That should be equal to the two parts, which is the area of our circle, using the wrong color, plus whatever our unshaded region in, all these little squiggles out here. And we said that unshaded region we're going to call X. So the area of our square should equal the area of our circle plus whatever X is. We can solve for X. Zing zadang, we got the area of the shaded region, non-shaded region. So the square is 15 times 15. So area of a square is just going to be 15 squared. And then the area of our circle is going to be our radius squared times pi. So that equals pi. And then our radius squared, which is 7.5 squared, that has got to equal x. So 15 squared, I'm pretty sure is 225. And then 7.5 squared is 56.25. Sorry, there's not enough space for this. Not space this out appropriately. Plus x. So that must mean x equals this 225 minus our 56.25 pi. So that is my answer in terms of pi. I'm also looking for my answer just to the nearest hundredth. So I'm just going to type that into my calculator. 225 minus 56.25 pi. And you can also use 3.14 if you're struggling to find the pi button on your calculator. So this is our answer, but we can also say our answer is 48.28. It's approximately the area of the non-shaded region. So both of these are correct. Depends upon if I'm asking you to leave your answer in terms of pi or round it to the nearest hundredth. All right, so now we're going to do a little mixing and matching and put these all together. I've got to identify what this shape is that's being asked for and then apply its formula. So first one is EFMH. So EFMH, and then we go back to E. So that is a kite. And my formula for the area of a kite is 1/2 the height. No, no. The diagonal 1/2 times the diagonal 1 times diagonal 2. Multiply those two diagonals together. So my first diagonal that cuts my shape in half is going from 1 to 8. So that's 7. And my other one that's cutting the kite in half is from F to H, which is 1, 2, 3, 4. So 1/2 times 7 times 4. So that equals half of 28, which is 14. So there's our first one. Next, we got triangle MGH. So I already know that is a triangle. And for a triangle, we've got to do 1/2 our base times our height. So let's find that triangle. So MGH. So so finding that triangle, I want the two sides that are going to be perpendicular to each other. So that's these two right here. So that means this area is 1/2. I've got a 2 and a 1, 2, 3, 4, 5. So 2 times 5. Well, That is half of 2 is 1 times 5. So our area is 5. Next, we got EFLH. So let's see who that is. EFLH. So that's this shape up here on the top. Well, that thing is a square, or I could also say that thing is a rhombus. And the area of a rhombus is the same as the area of a kite. So that is, let's see if I can write it right this time, half of diagonal 1 times diagonal 2. So my first diagonal is going 1, 2, 3, 4. So that's half of 4 times 1, 2, 3, 4. So half of 4 is 2 times 4, which is 8. So that rhombus's area is 8. Our last one is HMKJ. HMKJ is over here. So that thing is a parallelogram. Since it's a parallelogram, I know its area is just base times our height. So our base, we could use this as a base and then go perpendicular to it, but that seems super annoying. Why don't I go this one? Because then I can use this as the height of my parallelogram. So I've got 1, 2. So it's 2 times our height, which is 1, 2, 3, 4, 5. So its area is 10. And we are done. So keep in mind that all of these shapes are basically base times height, but triangle, we get too much stuff. Rhombus and kite, we get too much stuff. So we cut them in half. And then a parallelogram is really just a square. So it's just base times height, length times width. Thanks for watching. Bye-bye.